Good morning. Welcome to this lecture. We are dealing with collision in the previous one. Yes or no? We had seen that collision can be classified, and we had seen something known as the line of impact in the last question. Do you remember that line of impact?
Yes,
What is that line of impact?
line along which impulsive force acts.
Yes, it's a line along which impulsive force acts. This is the line passing through the common normal, and this is actually the direction in which the momentum, because the impulse is in this direction, this is the direction in which momentum of the body normally change. And we had seen how to find out this line of impact. In most of the cases, it is the common normal, but sometimes we can find it out from which direction, in which direction the momentum has changed. From there also you can find out this line of impact. Then we talked about the various classification of collisions, and we had seen that there are two types. Whether it is central, in central collision what happens is the center of mass of both the bodies, they lie in the line joining their center of masses, so that is known as the central impact. In central impact what happens is after collision the bodies only have translational motion. Do we understand this? Translation motion, and there is no rotation. In central impact there is only translation and there is no rotation, whereas in eccentric impact we can have translational as well as rotational. Do we understand this?
Yes.
Okay, now we are not going to deal with eccentric impact now. What we are going to deal with is the central impact collision, which happens in such a way that the center of masses of both the bodies will lie along the line of impact. Now, having said that, even here we have different types of collision. The first type of collision is known as the head-on collision. Have you heard about the term head-on? Head-on collision. And remember, this is a case of central collision. I hope you understand the meaning of central. The center of masses still lie on the line of impact. Now, what happens in this head-on collision? Some people also call this head-on collision as collision in one dimension. So this is collision in one dimension, or we call it the head-on collision. Now, what is going to happen in this head-on collision? What is going to happen in this head-on collision? Anyone knows this head-on collision? Anyone knows what happens in this head-on collision? No? In this head-on collision, apart from the center of masses of the two bodies, their velocities, their initial velocities of both the bodies, as you can see, the initial velocity of body A and the initial velocity of body B, they also lie along the line of impact. In that case, this is the line of impact, LOI, I call it, line of impact. This is the common normal, and you can see the initial velocities of both the bodies are along the line of impact. This type of collision is known as a head-on central collision, or head-on collision just for short. Do we understand this? This will be collision in one dimension. Do we understand this?
Yes.
Now, what happens if the velocities don't lie along the line of impact? Then such type of collision are known as oblique collisions. Such type of collisions are known as oblique collisions. So what happens in oblique collision? So what happens in oblique collision? This is again an example of central collision. The center of masses still lie along the same line, but you can also call this as collision in two dimension. So what happens here is the velocity of any one or both of the particles. It can be both of the particles, it can be any one of the particles. It does not lie in the line of impact. So this is the line of impact. You can see common normal line of impact. The diagram that we have drawn, the velocities of both the balls are not lying in the line of impact wala line. If any one of these velocities also do not lie in the same line, then we call that collision as oblique collision. Do we understand this? Yes or no?
Yes, sir.
That is known as oblique collision. So this is one way of determining what type of collision is there. This is one way of classifying the collision on the basis of line of impact. So you can, if you want, you can note it down. On the basis of line of impact, the collision can be divided into two categories. You don't have to draw the diagram, you just have to understand it. If you want, you can draw the diagram for better understanding. On the basis of line of impact, collision can be of two types. The first type is known as head-on or direct collision. The second type is known as oblique collision or collision in which the velocities do not lie along the line of impact. Do we understand this?
Yes, sir.
Okay. Then we can also classify collision on the basis of energy conservation. I hope you must have known this. On the basis of energy conservation. Now, how do we define collision on the basis of energy conservation? On the basis of energy conservation. Any idea, anyone? Everyone can see this better?
Yes, sir.
On the basis of energy conservation, how can we define collision? So the first type of collision is known as elastic collision. The second type of collision is known as inelastic collision. The third is perfectly inelastic collision. Now in elastic collision, what happens is, why it is known as elastic collision? Now when the bodies are colliding with each other, during collision, they get deformed. When they are colliding, because the impact is so much, the body get deformed. Now, after collision, these bodies want to regain their shape because that is the property that any body has. When you deform any body, it will try to come back to its original size or original shape. Now, if it is able to regain its shape completely, if it is able to regain its shape completely, then that type of collision is known as perfectly elastic or elastic collision. So in elastic collision, what all things you have to remember in elastic collision? Point number one, the colliding particles regain their size and shape completely. Point number one. They regain their size and shape completely. Point number two, no fraction of mechanical energy remains stored at deformation. Now, when a body gets deformed, some energy is lost. Either it is lost in the form of heat or light, or it is lost in the form of the deformation energy, deformation potential energy. In a perfectly elastic collision, obviously this type of collision is not possible. No energy is lost. The mechanical energy of the body remains conserved. That means the Total kinetic energy of the system before collision and after collision remain same. So these are the points that you must remember. If you want to write it point wise, I will give you point wise. Just first read it. In inelastic collision, the exact opposite of perfectly elastic collision is perfectly inelastic collision. This is the exact opposite of it. So here what happens? During collision, the body gets deformed. These bodies do not regain their shape at all. It's like something falling on mud. If a ball falls in mud, the mud gets deformed and the mud doesn't come back to its shape at all. It just remains in that deformed state. That becomes an example of perfectly inelastic collision. So therefore, the energy is lost in the maximum level because it is converted into other forms. Do we understand this? This type of collision is known as perfectly inelastic collision. Particles stick together. Do we understand this? Particles stick together. Now, when we talk about the third type of collision, remember a perfectly elastic collision is not possible. A perfectly inelastic collision is also not possible. The type of collision that we see in everyday life lie between these two, and they are known as inelastic collision. So in inelastic collision, what happens is the colliding particles, they try to regain their shape, but they cannot regain their shape completely. So therefore, they remain in a semi state where some of the shape is regained and some of the shape is deformed. Therefore, some mechanical energy is lost in the form of deformation energy. They do not regain their shape completely because some fraction of mechanical energy is lost in the form of deformation. Therefore, the kinetic energy before collision and after collision is not equal. Kinetic energy before collision and after collision is only equal in case of a perfectly elastic collision. Do we understand this? But in all these three collisions, the law of conservation of momentum can always be applied if there are no external forces apart from this. Now we will understand more. I will give more point wise thing about this. But first to write this down, then I'll tell you how collision happens and we will try to make more sense about it. So just write this. When you are done, please let me know.
Done, sir.
Okay. Now let us try to understand how this collision happens. There are three. You can understand this collision by this diagram that I'm showing to you, and I hope that this diagram will make sense. Okay, what happens in a collision? Now what happens in a collision? Now see, what we see here is a very simple example of understanding what happens during a collision. So we have two balls, let us say, mass m1, m2, initial velocity u1 and u2. And here you must understand that u1 should be greater than u2. So if u1 is greater than u2, then what will happen? Ball A will hit ball B. Yes or no?
Yes, sir.
No. After collision, what happens? These balls are again moving in a straight line. Just to understand, we are taking both balls moving in the same straight line, central collision, head-on collision. After collision, what will happen is they will move with different velocity. Which velocity will be more? V1 will be more or V2 will be more?
V V2, sir.
V2 will be more than V1. So V1 will be greater than V2. So what we see on the left hand side is the instant just before collision, and what we see on the right hand side is the instant just after collision. Do we understand this?
Yes, sir.
Hmm. In between, for a very short interval of time, which is shown from this point, let me make it with a different color. Between this point A and this point B is the part where the collision happens. Yes or no?
Yes, sir.
That is the time of collision. Now, what happens during this time of collision? Ball B, sorry, ball A. I have to name them. So let me call this as, let me call this as A and B. And let me call this as ball 1 and let me call this as ball 2 because 1 and 2 are used. Ball 1 is going to hit ball 2. Now, when ball 1 hits ball 2, what happens? They come in contact. Yes or no?
Yes, sir.
When they come in contact, forces will act on them and those forces will be impulsive forces. Yes or no?
Yes, sir.
When they come in contact, impulsive forces will act on them and they will start to deform. They will start to lose their shape and they will start to deform. Yes or no?
Yes, sir.
Now, velocity of ball A, velocity of ball 1 is more than velocity of ball 2. So ball 1 will start pressing ball 2. Velocity of ball 1 will start to come down and velocity of ball 2 will start to go up. Yes or no?
Yes, sir.
This will keep on happening. The ball 1 will keep on pressing ball 2 till a stage arrives when these two balls are moving with the same speed. Do we understand this?
Yes, sir.
They are both moving with the same speed v, and this is the stage which is shown here, middle stage. This is the stage of maximum deformation of the two balls. The two balls will be in the maximum deformed stage. They will be actually moving like one and they will be in the maximum deformed state. Both the balls will be moving with the same speed. Do we understand this?
Yes, sir.
So what is happening here, my dear friends, is when ball A is impacting ball B, equal and opposite impulsive forces are acting on them. Yes or no?
Yes, sir.
On ball 1, impulsive force is acting on the left hand side, while on ball 2, it is acting on the right hand side. Yes or no?
Yes, sir.
Because of this green force, impulsive force on ball 1, the speed of ball 1 or momentum of ball 1 is getting decreased. And because of this pink one, the momentum of ball 2 is increasing. Yes or no?
Yes, sir.
But at the same time, they are also getting deformed. Yes or no?
Yes, sir.
This type of impulse is known as JEE, impulse of deformation. Oh, we wrote impulse as I, so let me not use J then. Let me use ID, impulse of deformation. So this is the impulse of deformation on ball 1, and an equal and opposite impulse will act on ball 2, ID.
Yes, sir.
You understand this? So from this stage, when the collision begins, let me write it here. From this stage, when the collision begins to this stage, in the middle of the collision, this is the state of deformation. Do we understand this?
Yes, sir.
Now, what happens after this stage? After this stage, still the ball are in contact and impulse is acting on ball 1 as well as ball 2, but now the balls have come to the same speed. So what will happen? Now the impulse will still keep on acting on ball 2, on ball 1. On ball 1 it will be in the left hand side, and on ball 2 it will be on the right hand side. Yes or no?
Yes, sir.
But now the velocity of ball 2 will keep on increasing, and the velocity of ball 1 will keep on
Keep on
decreasing. So what will
decreasing.
happen? They will now start to separate from each other. Yes or no?
Yes, sir.
But to separate from each other, they will have to regain their shape. Yes or no?
Yes, sir.
Again, equal and opposite impulses are going to act on this ball. Now, we cannot call it impulse of deformation, so I call it impulse of reformation, IR.
Okay.
Now they are reforming, they are regaining their shape. Impulse of reformation, R. Do we understand this?
Yes, sir.
Because of this impulse of reformation, they will start to regain their shape, and at some point they will separate, and this is the point where they separate.
Yes, sir.
So from here to here, what is going to happen are they are going to reform their shape, right? So this is known as reformation. Do we understand this?
Yes, sir.
Impulse of deformation, impulse of reformation. If I find out this is force time graph, if I find the area of this force time graph, that will give me impulse of
Impulse.
deformation. If I find the area of this graph, that will give me impulse of.
Reformation.
If I add both the impulse, I will get the total impulse on the balls, on both the balls. That will be impulse of deformation plus or minus impulse of reformation. Do we understand this?
Yes, sir.
The total area gives the total impulse. One half of the area gives us the impulse of deformation. Other half of the area gives us impulse of reformation. Do we understand this?
Yes, sir. Yes, sir.
I'll give you 2 minutes to note this down.
Done, sir.
Draw it आराम से. Take time. Draw it आराम से. Write each and everything that is given there.
Done, sir.
Then the value of this, the ratio of this impulse of reformation divided by impulse of deformation is known as E. And this E is known as coefficient of restitution. This E is known as coefficient of,
Coefficient of restitution.
right.
Yes, sir.
Now this impulse of reformation, if you want to find, you can find out from the change in momentum of any of these balls. You can write it as M into, or sorry, M1 into V1 minus V, oh sorry, see, I'll just take you to the graph. See, written it wrongly. This is impulse of reformation. So impulse of reformation can be calculated from the change in momentum of any of the balls. The final momentum of this ball is m1 v1, and the initial momentum of this ball is m1 into v. Do we understand this? So from there you can find out the impulse of reformation. So what is the formula of impulse of reformation? The formula of impulse for reformation can be written as m1 into v1 minus v. Do we understand this? And that will be same as m2 into v minus u2. Do we understand what I'm writing here?
Yes, sir.
Similarly, you can write the impulse of deformation. Impulse of deformation will be m1 into u1. No, I've written it wrong. m1. Final minus initial. Finals minus initial. Okay. written it correctly. M1 into final velocity is v minus initial velocity is u1. I've written this one. M2 into the deformation, the final velocity is v2 minus initial velocity is v. But remember, for one case, for body number one, for one of the bodies, this impulse of reformation will be coming as positive, and for the other body, they will be coming as negative. Do we understand this?
Yes, sir.
In case of body one, v1 is greater than v, so it will be coming. V1 is smaller than v, so it will be coming negative, and on the other case, it will be coming positive, right? So we can write it in magnitude form, or you can write it in the positive form. So then I will have to change the formula. I hope I'm not confusing you. So you can write it in this way. This would be better. You write it as v minus v1, so that sign does not come into the picture. Okay, I don't want you to get confused with the sign. Anyways, no one is going to ask you this impulse of reformation and impulse of deformation. So this can be written as u1 minus v, or it can be written as m2 into v minus
Minus.
u2. So I have just taken the negative sign out and I have just written them positively. Do we understand this, what I'm saying here?
Yeah, yes, sir.
Now this impulse of reformation divided by impulse of deformation will be equal to E, and if you put the formulas correctly, you will get the formula like this: V2 minus V1 divided by U1 minus U2. This V2 minus V1 is known as velocity of separation. Do you understand this?
Yes, sir.
Velocity of separation. This U1 minus U2 is known as velocity of approach. Velocity of approach.
Yes, sir.
Now this value of E is always written along the line of impact. Remember that. So in 1D collision, we'll also write it along the common normal. In 2D collision, we also write this along the line of impact, because along the line of impact, JR and IR and ID act. And therefore, we write this impulse equation or this coefficient of restitution along the line of impact. Do we understand this?
Yes, sir.
Now,
Done, sir.
now for a perfectly elastic collision, or we call it elastic collision. For a perfectly elastic collision, the value of E will be equal to 1. For a perfectly inelastic collision, the value of E will be equal to 0. For the inelastic collision, 0 is less than E is less than 1. So the inelastic collision lies between
0 and 1.
0 and 1.
Yes, sir.
Then this is just a table which is you can write these points and I'll add more points to this. So perfectly elastic, inelastic, perfectly elastic. You first write these 3 points and then we will add more points to it. Just write these 3 points first. I hope you understand these 3 points. Yes,
Yes.
write these points. Have you written this, beta?
Yes, sir.
Everyone?
No, sir. 1 minute.
Okay.
Done, sir.
Okay. Then we will write more things here. The fourth thing that we will write here is particles regain their shape completely. Do we understand this?
Yes, sir.
Particles regain their shape completely. What will you write in the second column? Particles partly regain. You understand this meaning of partly?
Yes, sir.
Here, what will you write? They remain in maximum deformation state. Do we understand this?
Yes,
You
sir.
understand when they are maximum deformed? When in the middle of collision, they are maximum deformed. Do we understand this?
Yes, sir.
Okay. The next thing is equal and opposite impulse will act. Equal and opposite impulse act on the two bodies. Here also equal and opposite impulse act. Remember, impulse that are acting on the two bodies are always equal and opposite. Do we understand this?
Yes, sir.
And this impulse will always act along which line?
Line of impact.
Yeah, so this is common for all the three. It does not change. But here IR is equal to ID. Do we understand the meaning of this?
Yes, sir.
Here IR is less than ID. Do we understand this?
Yes, sir.
And here IR is 0. That makes your E as 0. Do we understand this?
Yes, sir.
Okay. Number 7. Next point. Kinetic energy before collision and kinetic energy after collision remain same. Um, then what you can write here perfectly. So we have noted this point. We can write here. Here we can write velocity of separation will be equal to velocity of approach. Do we understand this?
Yes.
Because E is equal to 1. So velocity of separation and velocity of approach will be 0.
Are equal. Yes, sir.
Do we understand this?
Yes.
Here velocity of separation would be less than the velocity of approach. Do we understand this?
Yes, sir.
Here they move as one body. If it is a 1D collision, they will move as one body. If it is a 2D collision, you must remember velocity of separation is 0 along the line of impact. Do we understand this?
Yes, sir.
Note it down. I'll give you 2 minutes, then I'll give you more points.
Done, sir.
Okay. Then we can write one more point. Law of conservation of momentum is valid. Here also, and here also. The only thing is, law of conservation of momentum can only be applied if there are no other external forces apart from this collision wala forces. Sometimes apart from these colliding forces, there are also impulses coming from other points. So if there is no other external impulse apart from this, law of conservation of momentum should be valid. Do we understand this?
Yes, sir.
Note this down.
Done, sir.
Everyone has noted this down?
Yes, sir.
Okay. Then whenever a question comes of 1D collision, so you can draw a question of 1D collision and general formula for 1D collision, and this is the formula that you will never find in any of the books. This is my creation, so it will always remain with me. No one else in the universe knows about it. General formula for 1D collision. Now what we can do is we can make a general case for 1D collision, and remember, whenever you apply this formula for general collision, it has to be done with sign convention. Or all these are vectors. So if you take one direction as positive, the other direction becomes negative. Do you understand this?
Yes, sir.
So this is M1, M2, and I have taken this as U1 and U2. Do we understand this? This is the instant just before collision. Do we understand this?
Yes, sir. Before collision.
This is the just instant just before collision. The second instant that I am making, what is this instant?
During collision.
This is the state of maximum deformation.
Yes, sir.
This is the state of maximum deformation. Both of them are moving with the velocity of this. This is actually the velocity of the center of mass of the system before the collision. Remember, the velocity of the center of mass always remains constant. So you can write this point as well. Momentum is conserved. The last line you can write, velocity of center of mass should remain constant. Velocity of center of mass of the system should remain constant if momentum is conserved. Do we understand this?
Yes, sir.
Okay. They will move together with the velocity, and then this is the instant after
After collision.
M2, M1, V1
And V2.
moving like this. Remember, you have to apply this formula with proper sign convention. Do we understand this?
Yes, sir.
Now remember this small things. What you would know if in the question you would know the value of u1, u2, m1, m2, and you will also know the value of e. You would also know the value of e. So they will tell you that this is a perfectly inelastic collision. They would tell you this is a perfectly elastic collision, or they would give you the value of e, half, 1 by 3, 1 by 4, 2 by 3, 2 by 5, whatever. So these quantities would be known. What would be the unknown quantities?
Um,
The unknown quantities would be the final velocity v1 and v2,
yes, sir.
right? Now, to find this final velocity v1 and v2, normally what you get to do, or normally what you got to do, if you solve the question properly, you have to apply law of conservation of momentum, number one. Then you will have to apply, depending on the case, the value of E, V2 minus V1 divided by U1 minus U2. So you have got two equations, two variables. You can solve those equations and get the value of V1 and V2. That is the best possible way in which you can do this. But since every time you have to do that, you don't have to do it every time. What you can do is we can do it once and we can remember the results for later on. Here we are also not going to do it once. We are just going to remember the results because these are very simple to remember, and the best way to remember them is this. Think about what all things they can ask. Velocity of center of mass, it remains constant. Now,
Yes,
velocity of center of mass remains constant. That means before collision, whatever the velocity was there, the same velocity would be after the collision, and same velocity would be the velocity of both the blocks when they are moving together. Yes or no?
yes, sir.
So this will be equal to m1 u1 plus
M
m2
U2
u2 divided by,
M1 plus M2
that would be again same as m1 v1 plus m2 v2
by M2.
divided by m1 plus m2. Do we understand this? So this is the first thing that you have to remember here. The second thing that you have to remember here is the general formula of v1. So this is the best way to remember this general formula. V1 will be equal to 1 plus e times VCOM minus E times U1 with proper sign. So you can take one direction as positive, you can take this direction as positive. So everything else moving on the other side will be negative. So if two bodies are moving like this, both velocities will be positive. If one is moving like this, another is moving like this would be positive and this would be negative. Do we understand this?
Yes, sir.
If this is the value of V1, what will be the value of V2? Now you can tell me what will be the value of V2 looking at the symmetry in the problem. Apply your brain. Formula of V1 is like this. What will the formula of V2 look like?
Um,
No one knows it? Don't use your brain. That is the problem.
Serious.
Yes.
కన్ఫర్మ్ గా తెలియదు.
Sir, it is in U1 plus we should add U2.
So what is the formula?
1 plus E into VCOM minus EU2.
That is correct. That would be the formula. Okay. So I hope you have understood and you will remember this formula. This is a question, and these are the type of question that you will get straightforward straight away. Two identical balls are approaching each other on a straight line with a velocity 2 meter per second and 4 meter per second. Find the final velocities after elastic collision between them. So you have 2 minutes to solve this. Yes, anyone with an answer?
1 minute, sir.
Okay.
Sir,
Yes, bacha.
-4 and 6, sir.
-4. I don't understand the meaning of -4. -4.
V1 is -4 and V2 is 6.
What is V1? What is V2? I still don't know. So if I call this,
Final velocity.
I don't know. I don't see if you are talking in symbols. I don't understand symbols. Don't tell me which is 1 and which is 2. How will I understand it?
Okay.
This is 1. This is 2. Now tell me the answer.
Now V1 is -4 and V2 is 2.
Sir, it's positive direction in 2 meter per second.
Whose velocity? One's velocity or second's velocity?
Sir, first one's velocity is in positive direction. We have taken that. So we got velocity of first
Velocity of what?
final velocity of first body as -4 meter per second, and final velocity of second body is 6 meter per second.
No, that is not correct. How did you do it?
Sir, final velocity of first body is 4 meter per second and velocity of second body is 2 meter per second.
That is correct. That is correct.
So,
Well done. So how did you do it? Tell me.
substituting E value in V1 and V2 equations and
Yes, how did you do it? Tell me.
so using V1 and V2, that equation, sir, that both equations and VCOM.
Okay. Well done. Then first of all, you find out the value of VCOM. How much is the value of VCOM coming? I am just taking this direction as positive. So it will be VCOM will be 2m minus 4m
Yes, sir.
divided by 2m. Yes or no?
Yes, sir.
So it will be how much? -1, है ना? Then I can find the value of V1. V1 will be equal to 1 plus E. 1 plus E is 1 plus 1 multiplied by -1. Minus E is 1 into U1. U1 is 2.
2.
What do you get? You get it as -4 meter per second. V2. 1 plus 1 into -1. This is same for this. -1
into 4.
4. And now you will get this as -1 into -4, not +4.
Yes, sorry, -4.
You will get it as +2 meter per second. Did you realize something in this question? This ball after collision moves here with 4 meter per second. This ball after collision moves here with 2 meter per second. Do you realize something from this thing?
Yes, sir.
What? This ball got the velocity of this ball. This ball got the velocity of this ball. Both of them interchanged their velocities.
Yes, sir.
Do we understand this?
Yes, sir.
Both of them interchanged their velocities. That means if we pay attention, If we pay attention, we do not have to solve questions which fall in some categories. What we can do is we can understand, write some special cases, so that if a question comes from those special case, we can straight away write the answer. Special case number 1, M1 is equal to M2 and E is equal to 1. So this is the case of elastic collision
Collision.
between two bodies. So you can write it like this: elastic collision between
Two bodies.
two bodies of what? Same mass.
Yes, sir.
So what will happen in this case? Elastic collision of two bodies of same mass. V1 will be equal to U2. V2 will be equal to,
U1. Sorry.
what is the moral of this story? They interchange their velocities. They interchange their velocities.
Yes, sir.
Right? They interchange their velocities. Number 2, same case. M1 is equal to M2. E is equal to 1. And one of the bodies is at rest. Then what will happen?
Connection.
Say for example, U1 is 0. Again, they will interchange their velocities. Yes or no?
Yes, sir.
So V1 will be equal to U2 and V2 will be equal to 0. Again, they have interchanged their velocities. Do we understand this? Do you see me? Am I audible and visible to all of you?
Sir.
Bakka?
Yes, sir.
Okay. We have noted this down. Yes or no?
No, sir. Just give us 1 minute.
Okay.
से अलग है हाँ अच्छा Yes, sir. Sir.
Okay. Now, If E is equal to 0, that means we are talking about a perfectly inelastic collision.
Yes,
Do you
sir.
understand this? Then V1 is equal to U1. V1 will be equal to, not U1. V1, final velocity of 1 will be same as final velocity of 2. And that will be equal to velocity of center of mass. They will both move together. Yes or no?
Yes, sir.
Write this. They will both move together.
Yes, sir.
Now, there is a special case. Let me make a special case. Now, if one of the bodies, M1, is very, very large compared to M2. So this is the case of a body hitting a wall. Oops. Just give me a minute. It's went away. So this is the case of a ball hitting a stationary wall. This is moving with a velocity u2. This is a moving wall, moving with a velocity u1. If you don't understand how a wall will move, you can take the example of a ball hitting a truck.
Yes, sir.
This is my truck. My drawing may not be very good, but it serves the purpose. So this is a truck moving with a velocity u1. The mass of the truck is m1 and a ball of mass m2,
M2 moving with
the
velocity.
velocity u2. Now, in that case, what happens? This mass of this one body is very huge. It's huge. So what we can do is, when we find out the value of VCOM of this system, VCOM is M1 U1 plus M2 U2 upon M1 plus M2. This M1 into U1 is so big as compared to, M1 into U1 is so big as compared to M2 into U2 that we can just take it as initial velocity of U1 and that will be same as the final velocity of V1. Do we understand this?
Yes, sir.
So the velocity of this truck is not going to change. So it was moving with U1, it will keep on moving with U1. Do we understand this?
Yes, sir.
The only change that will happen will be in the velocity of body 2. Can you tell me what will be the velocity of body 2? That means, can you tell me what will be the value of V2 in this case? I'll give you 2 minutes to do this. This is a question. So I made this question into a special case. So can you tell me the answer? Your answer should come in terms of E. E. E.
Okay, sir.
Anyone?
1 minute, sir. Plus sound. Sir, it's 1 plus EU1 plus EU2.
Yes.
1 plus EU1 plus EU2.
It will be 1 plus E into U1. And if you take U1 as negative, whatever the value of U1 is, I'm not putting U1 as positive or negative, 1 plus E times U1 minus E times U2.
U2.
That is as simple as that. Now I can make subcases here. Subcases here. Subcases here. If Q1 is 0, that means this is a wall and it is not moving. If it is a wall and it is not moving, then what is the value of V2? Minus E times U2. Yes or no?
Yes, sir.
Now again I can put if E equal to 1, then V2 becomes equal to minus.
Minus U2.
So the ball will rebound back. The ball will rebound back with the same velocity, same speed, whatever speed it was hitting. Perfect elastic collision, simple example. You have a ball and you have a wall. Wall does not move. You hit the ball with some velocity. If it is a perfectly elastic collision, it should come back to your hands with the same velocity.
Yes, sir.
You understand this? So that is this case. I hope this is making sense.
Yes, sir.
Okay, now I can put a different case. Case number B. If E is equal to 0, it will stick. Yes or no? Perfectly inelastic collision, it will stick. Then what will be the value of your V2? V2 will be equal to minus of U1. No, plus of U1. Sorry, not minus. Yes or no? So it
Yes,
will
sir.
stick and it will move with the truck. If I throw a atta, that ball on the wall, it will just stick. It will not go anywhere.
Yes, sir.
And this, or it has gone above it saying bye bye. I'm going. Okay. Case number 3, simple case. I've done all this. If E is equal to 1 and U is not equal to 0, that means the wall is moving, then we will have V2 as
U1 minus
2 times
2 times. 2 times.
2 times
2 times
U1
U1
minus.
minus EU.
Do we understand this? Yes or no?
Yes, sir.
Okay. Everyone noted this down?
Yes, sir. Done, sir.
Then solve this one. A ball is moving with a velocity of 2 meters per second towards a heavy wall, moving towards the wall with a speed of 1 meter per second as shown in the figure. Assuming collision to be elastic, find the velocity of the ball immediately after the collision. This type of question has come many times. Not exactly this, but similar question, and I guess that it might come this time also. Two minutes.
Sir, is it 1 meter per second? V1.
Find the velocity of the ball immediately after collision. It is definitely not 1 meter per second. Try again.
Sir, it's 3 meter per second.
It is not 3 meter per second.
Okay, sir. Sir,
Yes.
is it 4 meter per second?
Why we are guessing? Sometimes we say 1, then we say 2, then we say 3, then we say 4. Sometimes you are going to get the correct answer, right? It is
Sir,
4.
is it 2 meter per second?
Why you are taking so much time? If you know the formula and you can't apply it, I don't know when will you be able to do this, beta. It's very, very disappointing that you have everything in your hands, still you cannot do it. This is body number 2, this is body number 1. Formula is right here, you can't apply it. Such a bad sign. 2 times u1. u1 is -1 minus u2. You can't do this. It's really very, very bad. I have no words to describe the shame I am feeling.
Okay, sir. Sorry, sir.
Not done. Can't apply a formula.
1 minute. 20 minus 1 minus 2 is equal to minus 4. V2 is equal to 2u1 minus u2. u1 ఏంటి u1 2 ఇచ్చినారు కదా అర్థమైంది u1 2 కదా u1 First diagram.
Have you noted it down?
Okay, yes, sir. Okay, yes, sir, yes, sir. Got it, sir.
Sure.
Yes, sir.
This is the next question. I hope you can give me an answer straight away. Three balls A and B and C of same masses are kept on a frictionless surface. In a straight line as shown in the figure, ball A is moved with a velocity u towards the middle ball B. If all the collisions are elastic, then the final velocities of the ball are. Velocity of body A is 0, velocity of body B is 0, body C is 0.
Sir, velocity of body A is 0, velocity of body B is also 0, then velocity of body C is u.
How did you get it?
So after colliding, A will come to rest and
Why? Why?
elastic collision.
Between what?
A and B. B is in rest.
Elastic collision between what?
When it is elastic collision, E is equals to 1, then bodies interchange their velocities.
No. Wrong. Half knowledge is very dangerous. Say it again.
Okay. Sir, elastic collision between the masses of same massing body, then
Not same massing bodies, bodies of same mass. Okay.
so
Now you are correct.
they will interchange their velocities.
Now it is correct. If you don't say same mass, then it's a problem.
Yes, sir.
Half knowledge is dangerous. Next one.
Wow, what is this whole identical? Both series here played in a level of Sir, body A will move in the opposite direction with same velocity, and body D will move in opposite velocity to its initial velocity with same velocity.
Do you understand this or no?
Yes, sir.
Pakka, sir?
Yes, sir.
No doubt, no?
No doubt, sir.
Thank God. This one. Read the question, give me the answer.
In a straight row, section of balls each moving velocity be polarity Sir, it is option B.
Pakka?
Pakka, sir.
पक्का ना? आगे बढ़े? Shall we move ahead?
Yes, sir.
This one. Everyone understand this or not?
Yes, sir. Wait a minute. Calculating.
No, the previous question I was asking. Everyone understands it? This one. These are the type of question that you are going to get in the exam. I hope you will be able to do them. Sphere of mass 0.1 kg is attached to a cord of length 1 meter starting from the height of the point of suspension. The sphere hits a block of mass m at rest. What is the kinetic energy of the block after collision?
Which block?
Yes. Do you
Sir,
want
wait.
answer?
1 minute, 1 minute, sir. 1 minute. Give us 1 minute.
It is not a question of 1 minute.
Sir, it's C, sir. 0.1 joules.
C is definitely wrong.
It's wrong. Oh, shit, it's A. Sir, it's A, sir. Some calculation mistakes.
The calculation mistake have given you -5, bacha. Instead
Yes,
of
sir.
giving you +4, na?
Yes, sir.
You have lost 9 marks. That is how I calculated. There is a mathematical flaw in it, but that is how I calculate it. If you do one question wrong, you get -9 straight away. The calculation is wrong, but that is how I feel it. If I get it correct, I will get +4. If I get it wrong, I get it -5 because I will not get that +4. So ultimately, the difference between right answer and wrong answer is how much? It is 9 marks. So you think that way, you will not make a stupid mistake. So what will happen? With whatever velocity this strikes, it will move with the same velocity. Yes or no?
Yes, sir.
The velocity is same, masses are same, so the kinetic energy is same. So basically, the kinetic energy of this block will be equal to kinetic energy of this block. Yes or no?
Yes, sir.
Kinetic energy of this block is nothing but potential energy of this block, right? mgh
Yes.
is the answer, and that is the answer. Do we understand this?
Yes, sir.
Okay, chalo then we have made some beginnings today, and we'll try to do more questions. We will do 1 or 2 questions on oblique collision. That's it, because we will not be spending our time in those things which are not likely to come. So in tomorrow's class, we will be finishing your collisions. I've already sent you the sheets for collision and this.
Yes, sir.
Just do questions from that. If you are able to do those questions, that means you are in good space. You might find some of the questions that I am doing here. You might find them in the notes, but in the sheet, but that doesn't matter, because these are the questions that are going to come. Okay, so we'll meet in the next class, and in all probability we should be finishing with your collisions in the next class. So from Thursday, we should be starting your rotation. And by the end of next week, we should be finishing your rotation, whatever happens.
Sir,
So that we, yes,
sir, one more doubt, sir.
yes,
Sir, here he has that kinetic energy of the block after collision.
right.
Which block is asking, sir? Block A or block B?
Both are same, na.
No, no, sir. After collision, block B will be coming to rest, no, sir.
Block B will come to rest or block A
Sir,
will come
block A will be
to
coming to
He is
rest.
asking the kinetic energy of block B.
Sir, how can
Block,
we understand that? If options are given in that zero is also there.
then you should read the question carefully, my dear friend. A sphere, this is sphere. Hits a block. This is the block. You have not read the question carefully. In the diagram, they are both looking spheres, but A is sphere and B is block. Read the question. Do you read it? That is why this is the power of reading. This lower wala is block. Block. This upper wala is sphere. This is sphere. And this is block. So if you don't read the question carefully, that is what they are counting on, that you don't read it carefully. Don't
Okay,
read
sir.
it carefully, you are done.
Thank you, sir.
So
Have a
then in
nice
the
day.
next class, we will wind up your collision. And I hope you do practice. The more the number of questions you practice, I will be doing more questions here, at least 5 or 6, so that we cover the entire spectrum of questions that can come at any point in your exam. The rest of the questions are there with you. If you can do them, you are good to go. Okay. So we'll meet in the next class. Take care. Have a nice day. God bless you all.
Bye, sir. Have a nice day.
Bye, beta. You have understood this now?
Yes, sir.